Welcome again to my math tutorial. I'm available now just to share with you laws of indices. What are indices? Basically, indices are powers of numbers. I'm sure you've heard of uh, uh, digits reading a to the power 3 or 3 to the power 2, a squared. The power to a number is actually an index. And when we say indices, we're actually speaking uh, in plural form. So rule number one is as indicated in my video here, is that when you have a to the power n multiplied by a to the power n, basically the answer will be the addition of two indices, that is m and n. And so like in this instance, you see that a to the power n multiplied by a to the power n becomes a to the power m plus n. In the example in your picture, you can see that we have a to the power 2 multiplied by a to the power 3. And what do we get? We get a to the power 2 plus 3, which becomes 5. We may wish to prove whether this is true or false. A to the power 2, as you can see in brackets, is basically a times a. And a to the power 3 is basically a times a times a, as you can see in brackets. And so to get the correct answer, since the base of these multiplication figures are the same, we're basically just going to count the number of a's that are in the equation, which are 2 in a times 2, in a times a, sorry, and 3 a's in a to the power 3, which is a times a times a, and that gives us a to the power 5. Another example I'll show you numerically is this one, where it reads 2 to the power 3 multiplied by 4. So what do you get? You simply get 2 to the power 4 plus 3, which is 2 to the power 7. To simplify or to endeavor to prove my explanation, we can basically look at the above equation in this form. 2 to the power 3 or 2 cubed is basically as shown in my picture here. It's 2 times 2 times 2, and you are multiplying it by 2 to the power 4, which is also 2 times 2 times 2 times 2. So we have 4 2's on one side, and we've got 2 2's on the other side. Altogether we've got 6 2's. So 6 is the power. No, sorry, we've got 4 2's and 3 2's. So in total we've got 7 2's. So 7 is the index or the power. So we have 2 to the power 7 as the answer, as shown in the previous example, which was 2 to the power 3 multiplied by 2 to the power 4. We basically just added the two indices in this instance, which are 3 and 4, and that gave us 2 to the power 7. Let's go to rule number 2. And this is explaining the law that you follow when you're dividing indices. In this example, you've got a to the power n divided by a to the power n. A to the power m divided by l to the power n. Basically, what you do is the opposite of what you do when you're multiplying, where instead of multiplying the two indices, you basically subtract the second index from the first index. In this instance, the first index is m, the second index is n. So if I'm dividing a to the power m by a to the power n, I'll simply subtract n from m as indices to the base of a. An example is a to the power 5 divided by a to the power 3. We basically are going to retain the base, which is a, and subtract the second index, which is 3, from the first index, which is 5. Thereby, we're going to have an answer of a to the power 2. This can be proved as follows. A to the power 5 will simply give us 1, 2, 3, 4, 1, 2, 3, 4, 5 A's. Now we're dividing them. We're dividing this set of figures by a to the power 3, which is 3 A's. A, which is 1, 2, 3. So if we go by the law of elimination, as we are dividing, we'll cancel A here and cancel A there, cancel A here and cancel A there, cancel A there and cancel the A there. What we're going to see is actually that the denominator, which is a to the power 3, is completely eliminated, and we remain with 2 A's, which gives us a to the power 2. What about in an instance where you've got an instance where you have a digit, like here in this case we have a to the power n to the power a to the power m to the power n. You basically multiply, in this instance, m and n. As an example shown, we've got a squared to the power 3. To find your answer, you simply have to multiply these two figures here, which gives us 6. It can be proved. A squared to the power 3 is basically a squared is basically a times a times a times a 3 times, and that gives us 1, 2, 3, 4, 5, 6, and you got a to the power 6. Also get to know that any digit that has got an index of 0 has an answer of 1. So even if you have 10 to the power 0 or 100 to the power 0, your answer will be 1. In this instance, 6 to the power 0 also becomes 1. Rule number 5. What about when you have negative indices or negative index? How do you represent this index? Basically, like when you have a to the power negative 1, you're simply saying it will be equal to 1 over a to the power 1, which is 1 over a. Or if you have a to the power m, your answer basically would be 1 over a to the power m. In this instance, there's an example of 2 to the power negative 1, which is basically half. You simply have 1, because it's an inverse of 2 actually, so you simply have 1 over 2 to the power 1, which is half. Rule number 6. You have an index which is a fraction, a to the power half. How do you represent it? Basically, any digit to the power half is basically a square root. So when you have a to the power half, you're simply saying find the square root of a. And when you have a to the power, in this instance, to the power 1 over q, you represent it in this format, where the q, which is the denominator in the index, the q, which is the denominator in the index, will basically be the root. So you have root q of a as the answer. Let's look at this other example. 4 to the power half. We're simply saying square root of 4, which is equal to 2. Which is the root of, which is the square root of 4. So I go on and I bring another illustration. Apologies for that. Which is rule number 7. What about a to the power p over q? How do you represent it? You represent it in this format where you say a to the power p brackets 1 over q, which is root q of a to the power p. You could have a question as follows: 3 to the power 2/3. Simply say 3 squared to the power 1/3, which is basically the cube of 3 squared. A to the power p over q will look like explained above. In this instance, you will simply write 1 over q, a to the power 1 over q brackets p, which is just another way of writing this other first example in rule number 7, as can be seen by the brackets indicated. I hope you've enjoyed my short presentation. I want to click on the like button if you have enjoyed my tutorial, and subscribe if you have not subscribed before. I'm very open to receive advice on how we can make our presentations better than ever before. I look forward to seeing you on the other side. Enjoy this moment.